And we are clear.
Wow, that's about time. Been waiting for this all day.
Okay, let's gather around, everyone. Okay, let's make some room for Roboraptor.
But he's too big. Fine.
Okay, we have a new face
this is
tonight.
exciting.
Let's all say hi to Robo Rover.
Hi there.
Hey there. Hello.
So, what's going on?
I'm a Robosapien,
A Robosapien. That sounds so
and welcome
cool.
to Robot Adventures. This is a course I teach to get all the toy robots ready for the outside world.
Don't forget to tell Robo Rover that Friday nights are movie nights.
Yes, Drybot, Friday nights are movie nights. And now Robo Rover knows.
What's there to know about robots? They're just machines.
Oh no. I can't believe you just said that.
He's in for it.
Oh my gosh.
Did he just say what I think he said?
I think he just said it.
A robot is more than a machine.
Looks like we're gonna have to start from the beginning with you.
This is our teaching assistant we call the Wizard.
Welcome.
Hello, Wizard. We have a new student, and I'd like to start at the very top if we could.
The top?
Yeah, what is a robot?
Oh boy, this is gonna be so much fun. Hey, thanks for holding the spot for me. That was really nice of you. Backing up.
Anyone have any popcorn?
A Vision One newsreel proudly presents Robots on the March.
A robot is a machine that can complete a series of actions normally performed by humans automatically or by remote control. Robots have many uses today. They can be used domestically, for industrial work, space exploration, to help perform surgery, or to simply entertain. The word robot comes from the Czech word robota, which means forced work or labor. It was introduced to the public in 1920 by writer Karel Čapek in his play Rossum's Universal Robots. The play is about artificial people made in factories called robots who rebel against their creators. The word robotics, used to describe this field of study, was coined accidentally by the science fiction writer Isaac Asimov in 1941.
Wow, that was a lot of information.
Let's just see how well you were paying attention.
Which Czech word did we get robot from? A. Robota. B. Roboto. C. Ribbit.
How about B, Roboto?
The correct answer is A. Robota.
Looks like we have some work ahead of us. Wizard, tell us about how long robots have been around.
Programmable robots date back as far as the 13th century, with these humanoid robots that would play music. Around 1495, Leonardo da Vinci drew sketches for a robotic knight, but it wasn't until 2002 that someone actually built it. In 19th century Japan, they had a robot that served tea. In the 20th century, the creation of robots excelled by leaps and bounds. The first industrial robot, the Unimate, was invented in 1954. Although it was capable of a variety of tasks, the Unimate was sold to General Motors, who used it to lift and stack hot pieces of metal from a die casting machine. I have access to a factory that utilizes both human power and robot power to perform this exact task. Would you like to visit?
Yes. Let's show Robo Rover what a robot can do.
This factory produces chisels for commercial and industrial use. They recently installed a robot.
My name is Michael Joseph Melgid. I work for Ajax Tools. I've been here for about 10 years now. We purchased a robot last year to be more competitive in the market and also to ensure a little bit more safe operation on the shop floor.
Robots are making industrial workshops safer, as well as more productive. This worker shows us the original human process that the new robot has been programmed to replace. When the work is viewed side by side, the robot is faster, but more importantly, there is no risk to human safety.
Robots has been very exciting and a very rewarding tool for us, so it's been good.
Robots are now in widespread use in a variety of industrial factories, performing jobs more cheaply and with greater accuracy and reliability than humans. Many assembly lines and warehouses are now managed entirely by robots. But this robot revolution is only recent. For most of the 20th century, human workers were required to perform repetitive tasks for long hours at a time in order to streamline production and lower the cost to the consumer. In essence, humans had to act like robots. The worker assembly line over the past 4 decades has seen the turn to robotic automation. No longer needing a large workforce, a company can move an entire warehouse with minimal human interaction. What is the name of the first industrial robot? A. Steve. B. The unibrow. C. The unicycle. D. The unimate.
Is it D, the unimate?
The correct answer is D. The unimate.
Good job, Robo Rover. Now let's teach you the difference between a robot and a machine.
Electronic circuits enable robots to move. These circuits are controlled by a central computer system known as a controller. Together, they make up the robotic control system, or the brain. Much like the human brain, which tells the body what to do, a control system tells the robot's body, which is made up of motors, actuators, grippers, gears, and wheels what to do. The control system executes instructions that are loaded into its memory in the form of computer programs. Different programs can be designed to make a robot perform different tasks. A robot's body is similar to that of a human body. Much like a human has joints, the robot has axis points. Movement is represented at these axis points. An axis on a robot is most often controlled with a specialized motor called a servo motor. A servo motor constantly reports back its position to the robot controller. This way, the robot knows where all its axes are and how fast they are moving at all times. A gripper is a mechanical hand designed for a specific task. There are many different kinds of grippers, from the large grippers that can pick up boxes to the small ones that can pick up dice. Although many grippers work with proximity sensors to let them know where to grip, some robots have touch-sensitive pads built into the grippers that enable them to pick up delicate objects without breaking them. Other types of devices, called actuators, can also control robot movement. Actuators function like muscles or ligaments on the human body. Although robots cannot feel emotions, they can be built to have senses. These sensors tell the robot about its surroundings. A sensor is a device that a robot uses to measure some attribute of its environment. For example, a laser or acoustic sensor can be used by a robot to measure how near or far it is away from an object. These are known as proximity sensors. A robot may also use sensors to measure temperature or pressure, like those in space exploration robots. Another type of sensor system is a vision system. A vision system uses cameras to recognize objects and determine properties of those objects. This robot is a prototype. It is placing colored pegs in various patterns along the grid. Here is one that is used by casinos to count poker chips. Because they are the same size and weight, the robot uses a vision system to determine the values. Vision systems function much like the way the human eye sends information to the brain. The Mars rover uses a vision guidance system to navigate the difficult and unknown terrain of Mars. No matter what sensor system the robot uses, each one works within the Cartesian XYZ system. Simply put, each letter represents a plane in a three-dimensional space. The robot moves in accordance to points that intersect at all three planes. What makes up a robot's control system? A. A motor and an actuator. B. Electronic circuits and a central computer system. C. A computer program and fuses. The correct answer is B. Electronic circuits and a central computer system. Name all of the parts that the robot's control system manipulates on a robot's body. A. Radiators. B. Wheels. C. Condenser. D. Actuators. E. Stomach. F. Sensors. G. Motors. H. Printer. I. Grippers. J. Face. The correct answers are wheels, actuators, sensors, motors, grippers.
How did you do, Rover?
Wow, that was a lot of parts to remember. Let's just say I'm going to need to study.
Now that you know what a robot is, let's learn a little bit about the different types of robots.
Different combinations of parts determine the robot's capabilities and classification. These parts, working together, control how the robot operates. The main types are articulating, autonomous, gantry or Cartesian, and humanoid. An articulating robot is a robot that uses rotary joints, or axes, as we have called them, to create its movement. A rotary joint means that the motor, which has a shaft that rotates, controls the movement of each of the robot's axes. An autonomous robot can perform tasks in unstructured environments without continuous human interaction. They are programmed to carry out a specific task and can do so on their own. Robots that sweep floors, organize warehouses, and even the Mars rover are examples of autonomous robots. A gantry or Cartesian robot is a robot that is mounted on an overhead linear or straight line system in which it moves back and forth on. A humanoid robot is a robot that resembles the human body. Asimo from Honda is an example. While developing Asimo, Honda had many obstacles to overcome. Asimo had to learn how to stand properly and then walk before it was ready to join the humanoid classification. Now able to walk on two legs, the sky is the limit to what Asimo can achieve. A humanoid robot is meant to interact with environments and tools made for humans. Asimo is programmed with a degree of artificial intelligence. Artificial intelligence, or AI, is the ability for a robot to process information about its environment and think to achieve a task. This allows Asimo to make decisions based upon situations in its environment. Because of this, it is able to interact with humans. Robots can also be classified by what environment they're designed to operate in. Some typical examples include stationary, ground, underwater, aerial, and microgravity. Stationary robots are fixed in one place and cannot move. This category includes robotic arms, computerized machine tools, and most industrial robots. Ground robots are designed to operate on the surface of the Earth or other planets and are usually subcategorized by their drivetrain, wheels, tracks, or legs. Underwater robots, also known as autonomous underwater vehicles, are designed to operate underwater, possibly at great depth. Aerial robots, also known as UAV or unmanned aerial vehicles, are various kinds of robotic flying machines. Microgravity robots have been designed to operate in low-gravity environments such as Earth's orbit. Satellites and telescopes that operate in Earth's gravity are examples of microgravity robots. Which of these robots is an autonomous robot? A, B, C, The correct answer is B.
So now that you know what a robot is and the different types of robots, this takes us to the final part of our introduction to robots. Why make robots?
Dull, dirty, and dangerous, also known as the 3 Ds, have normally been used to describe the purpose for robots.
With your kind attention a song I will thrill. All you must toil with the pick and the drill, and sweat for your bread in that hole in Oak Hill that goes down, down, down. When I was a boy, said my daddy to me, stay out of the mines, take my warning, said he, or with dust you'll be choked and a pauper you'll be broken down, down, down.
Mining, known to be both a dirty and dangerous job, has dramatically changed as robots have been introduced. The manufacturing industry has most been affected by the introduction of robots. Many of the assembly jobs were dangerous and dull. Welding hot steel on an assembly line created a higher risk for mistakes and accidents until robots took over. The medical community has always been a leader in advances in technology in helping the sick. The danger of certain surgeries has been dramatically reduced with the use of new robotic-assisted procedures. The first robotic surgical arm was the Puma 560, used successfully in 1985. Since then, the Da Vinci surgical system has become one of the industry leaders in robotic-assisted surgeries. Pathway Genomics is using robots to process and categorize the human genome, while nanobots are currently being designed to help rid diseases from the human body without the need of medication or surgery. Space exploration, another dangerous endeavor, now uses robots to gather information about the solar system. What do the 3 Ds stand for? A. Dirty, dynamic, and dreary. B. Dark, dusty, and delightful. C. Damp, dapper, and dumb. D. Dirty, dangerous, and dull. The correct answer is D. Dirty, dangerous, and dull.
Are all robots just made for work? What about for fun?
Are you kidding me? Look at this place. We're all built for fun. And there are many places where you can go and buy robots or even build a robot.
Robot City Workshop is the robot store. You can come in, play with robots, get a little hands-on technical help, check out workshops, check out what's happening in robotics, magazines, books, anything robot related, we have it. Well, there's nothing quite like building your very first robot and just building robots in general, because it is fun to have something that actually moves around and makes decisions that you created. So this is James, and we're currently in the middle of building a line tracker robot from Elenco. And we're going to be learning a little bit about motors, gears, basic robot sensing today. A robot is comprised of electronic parts and mechanical parts. Circuits and electronic components will form together to make its brain, and you also have mechanical parts which will make its body, which will have its muscles and its skeletal structure. A gear is a little circular piece that has ridges on it. When you use gears in conjunction with each other, it's going to make it a lot more powerful than just a wheel by itself. Motors are what make something actually go. It's like a robot's muscles, basically. It's just something that'll turn a wheel, and then depending on what you hook up to the wheel, it'll either make an arm go up and down, or it'll make wheels go, or it'll make legs work. And that's the very basic something of a robot. We are on the cusp of the robotic age. So in the next probably 10, 15 years, robots are going to be doing a large majority of the household tasks. We'll use them to actually help out around the house. And they have a robotic vacuum that's totally automated, and it'll scoop around your house just picking up dirt. They also have ones that clean out your gutters. The dishwashing robot, where it picks up dishes out of your sink and it puts them into your dishwasher, and it closes your dishwasher and turns it on. They actually have one that mows lawns. It's solar powered, and they have robots that can recognize facial expressions. I know there's tiny humanoid robots that they'll actually put inside you. Pets, robotic pets they have now. That's about it, actually. Well, if you're looking to get into the field of robotics, I'd say subjects like math and shop and just mechanical design and stuff like that are important, but the more comfortable you are with knowing what a robot actually does, and including the more basic elements of it like electronics and mechanics, the better you're going to be suited for the world that's coming up.
My name is Antigone Sherris. I'm an instructor over at Triton College in the Engineering Technology program. My purpose here is to be a mentor for the robotics team at Proviso Math and Science Academy. Last year we went to a competition over at UIC. We competed with 50 some odd other teams.
We compete in the first robotics competition, which is sponsored by Dean Kamen, who is a nationally renowned inventor, creator of the Segway. This competition pits teams all across the world against each other to create a robot. And this robot completes a challenge, which is different every year.
Our robot had to pick up balls and throw them into another robot's nest.
Well, we built Monty 3. On the team, I worked on the chassis. I kind of put together the wheels and also helped build the chassis, which is the base of the robot.
I help make the robot move, and during competitions, I help control the robot.
I was the computer programmer, so I basically programmed the robot to do the different movements that it did. So like the elevator that we used to bring up the moon rocks up and to release the moon rocks onto the other opponent's robot.
My job was in the electronics, setting up the wires and making sure all the pistons worked when we shot the balls out of the ejecting slot.
My main role in this robotics team is to be able to is the 3D modeling. In robotics, you actually get to build a robot, and you have to know how the robot works in order for it to work in the first place.
We're in FRC, First Robotics Competition, which is widely known, and they actually work very closely with the engineering colleges of many universities.
With the 4 years of robotics, I'll be able to get into any college that has a really good engineering program.
Well, I see myself in the future as actually maybe programming robots.
I want to be a mechanical engineer.
Either an astrophysicist or a solar engineer.
Aerospace engineering.
I hope to be programming.
Civil engineering.
Well, I'm applying to West Point.
I'm interested in medicine. There's a lot of surgeries and things that are done using robots and robotics now.
I want to be in the medical field. There's this new machine called Da Vinci, and that really makes me happy when I'm working with the robots that they're going to be using machines to help people get better in life and live longer.
The word robot is a very generous word. Anything that's automated, which has an actuator and some kind of electrical circuit running a motor, and causing something to happen because of a reaction or an action to it, is essentially a type of robot. So it's in our lives.
Wow! Tribot, you were right. You can have a lot of fun with robots.
It's just the beginning, Robo-Rover. Robots are now a part of our everyday lives, which leads us to our very last question.
Which of these career paths uses robots? A. Engineering. B. Medical. C. Military. D. Space exploration. E. Construction. F. Agriculture.
Robosapien, something is wrong with this question.
You're right, Robo-Rover. It is a trick question. They all use robots.
Oh no, the owner is back. It's morning already.
Okay, everyone, back to your places as fast as you can.
Okie doke. Now, was I supposed to pay attention where I was?
Oh no, where was I at? What was my position? Everyone, out of my way, out of my way!
I believe I hear the sound of keys.
We're all done for. I can't go back in the bag.
This looks like a good place.
Just park it and shut down.
Until we meet at the next robot adventure, have a great day.